on to this joint AWS and COVID webinar. It's great to see so many people here. Thanks a lot for taking the time to look with us through the next webinar. This is actually webinar 5, where we look at container frameworks on AWS, where we look at Docker, ECS, EKS, Fargate. This is the topic today. We will not touch too deeply on Kubernetes, because Kubernetes is what we will have in the next session. But obviously, I will show you what EKS is and how we use it as well. So the agenda that we have prepared is we will do a small introduction for why we do run containers on AWS. We look at ECS, at Fargate, at EKS, and at the very end I have prepared a demo where I show you that in real life how ECS and Fargate actually looks on the AWS platform. For those of you that are the first time on this webinar, everything is recorded. You are all mute. So if you have a question, please type it in the Q&A window, in the chat window, which you see on the right-hand side. I will monitor it, and if I see a question, I will try to answer it as it comes up. The webinar runs for roughly 45 minutes, maybe 40 minutes or so, depending on how much I plan to talk about and how long the demo will be. So roughly at 4:45, we should be done with this webinar. For those of you that have not participated yet, I'll give you a very brief introduction who COVID is, and I will introduce myself as well too, so that you see who is presenting here and what our experience is in the AWS environment. So COVID AG is a company that was founded roughly 4 years ago, middle of 2016. We focus entirely on AWS, so we are a cloud-native company. We do containers and Kubernetes. We do a lot of automation with Puppet for on-premise environments. We do obviously as well cloud consulting, Agile, Safe, Less, Scrum, these things. And we do have a few people that focus on IoT as well. By now, we are 13 people. We are spread over Zurich and St. Gallen, and we work with quite large customers in Switzerland to build up their cloud experience, cloud environments, and container platforms. And automation, obviously, is quite a big thing as well. To me, as a person, I have been in IT for 25 years by now, 15 years of those at Cisco. I left Cisco and at early 15. And then I went 3 years to Australia. I had quite a good experience there, working very early in the cloud journey at 2 AWS partners. I did a lot of cloud-native stuff, deploying VMs and containers and serverless. CI/CD and DevOps were really hip already in 2015, so I learned a lot there. But then I came back end of 2018, joined COVID. It's roughly 2 years now, and I have been a partner working with the folks here to build our AWS business and container business, and getting highly certified as a company, but also as a person. I do hold 2 pro certifications at AWS, the DevOps and the Solution Architect Pro, and a lot of smaller certifications as well. I have also been certified as a Kubernetes admin, and in the past did VMware and Cisco things as well. And during my 7-8 years working with cloud environments, hyperscalers, I have been able to work with AWS quite a bit, with Google, and also with Azure more recently, to have insights and have the ability to compare these platforms too. So now going to the introduction of what's happening in the IT environment, and if you look over the last 25 years, we have seen quite a shift between how applications were built 25 years ago to how we build it today. So when I started in the 90s, there were quite a few mainframes around, and obviously on mainframe we had monolithic applications provisioned in one piece. Luckily, I never had to really work with these mainframe environments. I really started to work with open systems, so I really never touched a mainframe as an ops guy. Just had to fill my timesheets on these mainframes. Luckily, I never had to program anything on them. So with the open systems, it was the Unix systems, HP Unix, AX, a bit of DEC, Windows, and Novell systems. They brought in the client-server applications. So it switched there from monolithic applications to pure client-server applications. Then in the early 2000s, the internet push, the web applications came up, where we have seen that these applications were built on N-tier applications. So UI tier, app tier, DB tier, provisioned on different instances. And then the VM push, virtualization push came in 2005, 2008. We saw that lots of companies started to adopt VMware and Hyper-V and so forth, and that also brought new application architectures with microservices over the past decade that came in. And now more and more we see cloud-native infrastructure built on containers, on serverless technologies, and that's exactly what we will talk in this webinar about. So these application architectures, where they start to put in microservices into smaller environments, really drove the whole container build up. And this is what we look at now over the next roughly half an hour. What are typical use cases for containers? So the microservices that I mentioned before mainly came from the dev area. So Java developers, Node developers, Go developers, they wanted to have the ability to break up their applications into smaller pieces and start to let them communicate via REST APIs with each other. So they required something that is more portable and easier to handle, is more agile, starts quicker than a normal VM. So when Docker came forward with their runtimes, where they could handle a few hundred megabyte large images, they quickly started to embrace these technologies and started to put microservices into containers. Continuous integration and continuous deployment with CI/CD pipelines, they need to build these architectures and structures with infrastructure as code. And with VMs, particularly in a private environment, it's quite hard to build infrastructure as code. With containers, with a good container orchestration solution, you build up these definitions with Kubernetes YAML files or with Compose YAML files very easily. Then the application developers, they want to experiment. They want to use lots of different tools and technologies, and they are very used to download container images for caching or for using new tools, Nginx and Apaches, and doing other kinds of microservices. They download pre-built container images, and they want to integrate them into their PaaS stack for their application deployment. And that's a very good use case as well. Then machine learning or start testing or IoT is also good use cases that can be used and put into containers too. Now, what's the container landscape at AWS? Let's structure it in three different areas. So we do have the management, we do have the hosting, and we do have the image registries. Because the container features and functions and services at AWS have grown quite a bit over the last 6-7 years with all these different flavors and tools that came up. So for the orchestration, we have two main flavors that we can use. We have ECS as Elastic Container Service, and we have Elastic Container Service for Kubernetes, which basically is a competing orchestration and scheduling technology compared to ECS. Why do we have two at AWS? The reason for that is that actually AWS had, before that Kubernetes actually came out, they already had a container orchestration solution available with ECS. So ECS, if I remember correctly, was launched in 2014, 2013, that time frame where Kubernetes was still in development phase. So Kubernetes was released as open source and donated to CNCF around 2014. So AWS already had something out as a service. That's the reason why we do see two different container services at AWS. If you look at the other two hyperscalers, at Google and Azure, they both stick to Kubernetes because they launched these services much later than AWS did. So, for example, obviously Google has Kubernetes since probably 2015 or so, early 2015, shortly after Kubernetes came out. Google compute engine, a container engine, what it was called at that time, was launched pretty quickly. So they have embraced Kubernetes from the beginning, and Microsoft came out of it probably 2 years ago or so, 3 years maybe, with their Kubernetes service. Then for ECS, but also for Kubernetes, you have two options how you can execute or host these worker nodes. That's just the worker nodes. You will see that later on what the difference is between the master nodes and the worker nodes, or the control plane and the worker nodes. You can run it either as EC2 images, or you can run it in Fargate mode. With EC2, you have a real EC2 instance available where your Docker containers will be launched on, and with Fargate, it's also the worker nodes that are fully managed by AWS themselves. And for the image registry, there is just one service. From the beginning, Amazon had the Elastic Container Registry available, and that is good to host container images for ECS, but also for EKS, where you can store the images in. Important to understand is that, for example, Kubernetes never has a container registry built in with the normal open source technologies. So container registry or container build is always something that runs outside of the container services, also for ECS and also for Kubernetes. That's with all the offerings that you see out there, that the container registry is not part of the container service. But all of the providers, obviously they do have a container registry. Here, if you know OpenShift has also a container registry built in, because that's basically a blend of all the technologies that are required to run a container service. Let's look at the orchestration tools, when to use which. As mentioned before, ECS came out 2012, 2013, and has quite a bit of history, and is therefore also very mature in terms of usage. So with ECS, you usually, if you are fully committed to AWS, if you know the next couple of years you will stay with AWS, you go ECS, because ECS is very easy to use, is highly standardized, uses CloudFormation as well. And if you know you stay at AWS, use ECS. It's cheap, it's easy to use, it's a good choice. If you're not 100% sure if you will stay with ECS or want an open source scheduling solution, you go with Kubernetes. And with Kubernetes at AWS, it is EKS, Elastic Kubernetes Service, and then you produce the open source YAML files. These are standard files that you can run everywhere. You can run these standard Kubernetes files on-prem. You can run it in OpenShift. You can run it at any provider that supports Kubernetes. You can run these files. So if you are unsure, or if you already have an existing Kubernetes installation and you want to move that to AWS, then you go with EKS. To the launch type, that's a bit more difficult to decide. So you will see later on what the differences are for between EC2 launch type and Fargate launch type. But in a nutshell, if you need high control of the EC2 nodes, for example, you need to mount file systems, or you need to have a specific EC2 agent running on it, or you need to have maximum control over these instances, then you run it in EC2 mode. If you only have a few containers and you don't care on what type of instances it runs, or you have short-lived containers and you only want to run it for a brief period, then you go with Fargate. And also with Fargate, you offload a lot of the management complexity of these nodes to AWS, so that they have to patch and monitor and maintain these nodes. So basically, with both solutions, you have the management plane, the masters, you have them fully managed, but with EC2, you manage the node yourself, and with Fargate, you also have the node management offloaded to AWS. And the same is with EKS. So the default mode is that you provision EC2 worker nodes, and then you have a secure shell login onto these EC2 instances, and you can do basically whatever you want with them, or you provision it as EKS in Fargate mode, and then your pods will be launched on fully managed worker nodes for you. So Fargate is super convenient to run. You don't have to do anything. It costs a bit more, and if you have a very high density, it probably is quite a bit more expensive than compared to EC2. Fargate costs have come down quite a bit in both in ECS and in EKS. The prices have been reduced over the last couple of quarters quite a bit, because the value of Fargate is super high that you get it, because everything is outsourced, but the price was a bit higher there as well. As mentioned, it came down. It's still not at the EC2 level. EC2 is a bit cheaper, but you have a lot more that you need to manage with EC2 based runtimes. So let's look into more details how they are structured, these services. So this is now the Elastic Container Service from AWS. So when you run containers on EC2 instances, obviously you need to have EC2 instances provisioned. AWS makes it today really easy to launch ECS worker nodes. you can launch it from the console, you can launch it from the CLI, even from CloudFormation. You fire in these tasks, they are provisioned via CloudFormation for you, and then they register themselves into the ECS master control plane, where all the control of these worker nodes is happening. So here you see the master control plane actually controls via the ECS agent these worker nodes. That's the whole cluster management, provides an API, and also have a small key value store that you can use, for example, to store parameters and stuff like that, so that you can offload a bit of content management into ECS as well. And obviously, you can also use parameter store and secret manager. That's super highly integrated, as always, with the AWS services. So if you want to use keys or passwords or anything like that, you can consume them very easily through the ECS control plane. And then the actual containers, they are started as tasks on these EC2 images, EC2 instances. So these Docker images are downloaded, executed via the container runtime interface, fully standardized via Docker. Is that stored. And obviously there's also an integration via the service elements. You see that later on in the demonstration via the load balancers, so that you can fully expose these containers in private networks via a public load balancer and reach them via the public internet. You can also do that via private load balancers, and it can also have them in multiple hierarchies, so that you have internal tasks and external tasks, and make them communicate with each other. You can really build complex environments with ECS service discovery and all these tools that AWS provides. And with Fargate, as I have mentioned it before, with Fargate, you fully offload the management of the worker nodes to AWS. So you don't have to provision, scale, or manage any EC2 instances. That's all fully handled by AWS. You basically give a task definition, a service to AWS, and tell them run that on Fargate, and then it provisions in the background the required EC2 instances to run it. You don't even see them; they are fully handled in the background. So it's a fully managed service also for the worker nodes, and you basically pay just the CPU memory that you consume for that particular container. If you run 1 or 2 or maybe 5 containers or smaller containers, that's very cheap and very efficient, super easy to do so. If you run thousands of containers, then you have to calculate really exactly that the costs don't go through the roof. And also Fargate is highly integrated with all the other AWS ecosystem, like the VPC networking, IAM permissions. You can use rows and stuff like that, CloudWatch, logs, and all these things, container insights, all available even with Fargate. Some people even call Fargate as serverless containers, which is a bit strange because you always have servers, but you don't have to manage these EC2 instances anymore. So it's really cool. Look at it if you start to experiment with containers. Super easy to consume. Here you see the difference. On the left-hand side, you see classic ECS, and on the right-hand side, you see Fargate with classic ECS or with normal ECS. You still manage these EC2 instances. You see them; they pop up in your EC2 console. And you need to upgrade them, you need to monitor them, you need to do capacity management. All of that is on your shoulders to do. If you use Fargate, the complexity of handling these EC2 instances is fully handled by AWS. You don't know how many CPU memory instances they run for you. You just hand them over these tasks, these containers. They will run, you pay CPU memory, and that's all what you do. It's super convenient to use. So a lot of complexity outsourced to AWS for them to handle. To the networking, networking is a bit different in Fargate compared to ECS. So with ECS, you can have a container internal networking if you require so. With Fargate, you always get an ENI. You know what an ENI is if you have used AWS before. So all your Fargate containers that run, they will have an IP address, a private or a public IP address inside of your VPC. So it consumes IP addresses from your VPC, make the VPC CIDR big enough so that you don't run out of IP addresses. And you put on each container task your security groups. You need to handle that as well. So that security is around these containers in a microzoned approach. So with Fargate, it's only ENIs. So really, each container is fully exposed, or each Fargate task is fully exposed inside of the VPC, and that's very different compared to the normal ECS. With normal ECS, you can have an ENI as well, but you can also have the private mode where the containers are not visible in the VPC and do not consume ENIs, do not consume IP addresses, and you need to protect it with other mechanisms. The good thing is with ENIs, you can have your security groups as you have it on the EC2 instances. So you can use security groups and NACLs if you require so. That's all fully available, but you need to manage it, obviously. And as you see, you also have public IP support. So if you want to do so, if you need to do so, you can give a Fargate container, a Fargate task, a public IP, but think about twice before you do so, because that means it is exposed to the internet. So talk to us, we can help you there to make it only exposed via an ALD, for example, so that they have more protection around those Fargate tasks than having them fully exposed to the public internet. So we usually design it in that way that we have first an ALD. The ALD handles the whole TCP splitting things, maybe even TLS splitting, TLS termination if you want to do so. And then we have the tasks in private networks so that only the traffic that should go through is reaching the containers. So that's the well-architected design that should be implemented if you can do so. But there are cases where you really need to expose that public IP. By now, even in Frankfurt, the NLB, the network load balancer, is supported. So even if you have UDP requirements or TCP requirements which cannot use ALB, you can use NLB to make these tasks private as well. So look into that before you make them public. Here you see an example application on ECS. It could be Fargate or normal ECS. So, for example, the UI comes in, resolves its name of the application load balancer over Route 53 for DNS requests. That the application load balancer hands the request over to tasks running inside of ECS. ECS is managed by the ECS orchestration And then the task here on ECS, which can be anything, Node, Java, Go, whatever you want, connects, for example, to an Amazon RDS Maria database where it stores its data. And as you know, you should always put stateless applications onto container environments. That's how you should build 12-factor apps, which are super well suited for containers. And here you see also the integration into other services, for example, to IAM to get roles to connect to RDS, so that you don't have to put secrets or passwords or keys or anything like that into these container images. You can use a role to connect to the databases, and use CloudWatch for monitoring and logging as very well integrated into ECS as well. And then we store the images in ECR, the Elastic Container Registry, so that the ECS cluster fetches the container images via ECR. And if you have a very modern microservice application which only needs a REST API, you can also blend in an Amazon API gateway, so that the API handling is also going over the API gateway. So for example, a single page application which sends its REST API calls to the API gateway, and that one sends it into the cluster to these microservices to handle it. Good, and then to close off the presentation, before we go into the demonstration, we look briefly at Kubernetes and EKS. And as mentioned before, we won't waste too much time on it because the next webinar, webinar 6, is fully focused on Kubernetes, where we look in detail what Kubernetes is and how AWS offers it as EKS as a service. So what is Kubernetes? Kubernetes is an open source system for orchestration. So it is a container orchestration solution that automates the deployment, scaling, and management of containerized applications. Kubernetes is fully open source. Kubernetes was developed it actually comes from Borg. So Borg is Google's internal container management solution, and part of Borg and part of Borg's ideas were open sourced and made available to the public as Kubernetes, and it basically brings in 15 years of experience of running production workloads at Google in container environments. So it's a highly sophisticated container orchestration and scheduling system. Interestingly, even if Kubernetes was invented and there's still a lot of maintainers from Kubernetes are at Google, and Google runs huge Borg environments and huge Kubernetes environments. But the CNCF survey has shown, I think that was done about 2 years ago or so, that still 51% of Kubernetes workloads run on AWS. Even if AWS did not have EKS since roughly 3 years ago, a lot of customers deployed Kubernetes manually with kops or other solutions. And still a lot of Kubernetes environments run on AWS. So that was quite interesting to see that figure, that so many Kubernetes clusters are well running at AWS. So if you provision an EKS environment, it spins up a master environment, the master nodes fully managed on the EKS platform, which is outside of your VPC. So the EKS control plane is a managed service, very similar, for example, to DynamoDB, or if you consume Microsoft Active Directory services on AWS, it doesn't run inside of your VPC. But the good thing is the control plane can fully blend into your environment via a similar thing as endpoints. So it is fully private service. You don't have to make it public. You can reach the control plane for your work nodes fully on the AWS backbone without any internet gateway connected. And then you have the worker nodes, and these worker nodes in the normal mode run inside of your VPC, spread over your 3 availability zones, and they connect to the API service via these internal connections that I have mentioned before. So if you provision EKS, you see these worker nodes, and you can also secure shell into them if you require so in normal EKS mode. If you do that in Fargate mode, then the same as with ECS, you don't see the worker nodes. The worker nodes are fully managed by AWS as well. Here you see how they can integrate together. So you have your customer VPC. Inside your customer VPC, you have your worker nodes running. These are classic VMs, EC2 instances. So you see just your customer VPC. It connects over the private endpoints into the EKS VPC, which you don't see. This is fully managed by AWS, and there AWS provisions the control plane, the master nodes for you in a fully managed way. And the third type is for all private. You can obviously go over the internet to consume it, but there is a flag. You can make it fully private, and then the master nodes are only reachable via the private endpoints, which you see then via ENIs in your VPC. So fully private clusters if you require so. And I do work with banks which really have the requirement to have fully private clusters. EKS can deliver that. Good. So now, while I start the demo, any questions so far? I talk a lot, sorry. I already have looked at the chat. Any questions so far? No, good. So first we go briefly over into my AWS account that I use here, and to prepare this demonstration, which is a live demonstration, I have provisioned outside of our service catalog the account, the networking. I have also provisioned a small ECS cluster because that will take too much time. It takes about 5 minutes to provision an ECS cluster. The networking takes about 15 minutes together with the account preparation. I have prepared that. So you see here, there is a small ECS cluster running. And I changed that. It makes it a bit easier to switch around. So if we go here to ECS, you see here we do have a cluster provisioned, but there are no services running currently on that ECS cluster. Now I go over into my command line interface, and here I use something that we have done at COVID. I launch a small product out of our service catalog that basically provisions a couple of CloudFormation templates, which will launch as sample application on ECS. So if I go back now and go into the service catalog and refresh here, if everything went well, I will have 2 new products which are in provisioning stage. And this is fully automated, obviously. I can't do that in a live demonstration, put in all the parameters and start a CloudFormation template. So this is all automated. And what it does is it creates a product and a CloudFormation stacks for me, which have all the things configured and parameterized for me. So what I do is I start two different applications, one based on ECS and one based on Fargate. So you see I launch two CloudFormation templates. Here you see the launch type set to EC2, and if I go to the other one, you see that the launch type is specified as Fargate. And I have also specified that I want to launch four tasks for Fargate, and I want to launch 3 tasks in EC2 mode. And obviously, if you are not familiar with CloudFormation, you won't be able to understand this. But what CloudFormation does is an infrastructure as code language that describes how the infrastructure should look at the end. This is something that we have written and we have built and have also exposed that into our service catalogs to make it really easy to consume for us. So you see, in one command, I pushed up two different ECS applications. And here you see what it actually does. It got 2 containers. One container is, where is it? One container is a BusyBox, and that BusyBox is actually doing every second it writes the new time. And the second one is an Nginx or an Apache, can't really remember. The second one, here you see the BusyBox, here it is. And the second one is an Apache 2 that is launched. So that's the same both for EC2 and Fargate. So basically for each task we launch 2 containers. So at the end we will have, let me calculate that, we have 12 tasks, no, not 12. We have 3 replicas running for EC2, and we have 4 running for Fargate. So you have 7 in total, 7 tasks, and each task has 2 containers. So we should have in a few minutes 14 containers spun up in this AWS environment. So what you see now, after having talked a bit of what we do, we have now 2 services running, one for Fargate and one for EC2. So if I go into the task definitions, I get 2 task definitions here as well, one EC2, one Fargate, that's still the same. If I go in here, I can see what each of them will do. So this task definition here is the Fargate task definition. It runs in VPC mode. That's what I mentioned before, because it will get all these ENIs attached to it. It will have a role for IAM, then this memory and the CPU is defined. Then we got 2 containers that are attached to it, one Apache, as you see that here, and one BusyBox writing the time. You see the same as you have seen before in the CloudFormation template. And most likely this application is already up and running. So you see 4 Fargate running tasks, as mentioned before, are running, and 3 EC2 tasks are running too. And the only difference between I think that's the Fargate one. Yes, correct. Need to go to the other. This one here, that's the EC2 one. So you see the only difference between the 2 is the compatibility, because we have written these templates to be used with both launch type possibilities. We can use it and change it on the fly from EC2 to Fargate, provision it, the template again, and it changes rapidly. So here the same 2 containers. So now these 7 tasks are up and running. Let's see over here, here. So when I now go into the tasks, I should get a 7. 1, 2, 3, 4, 5, 6, 7. So that's right. 4 for Fargate, 3 for EC2. And we will also have the services defined. Let me see what that is. So here, let's go into the Fargate service. The Fargate service, or actually the service object inside of ECS is something that defines how many replicas and how the traffic should be routed into the ECS cluster. So you see, we do have load balancing involved. So this one will create a load balancer in the EC2. We do have the subnets involved. We have a security group attached. And all of that is configured with simple service types in the ECS CloudFormation configuration. And now if you go over here to CloudFormation, that should be create complete by now, correct. So I go over, and this one here is the EC2 launch type. I go to output, here we see the URL for the load balancer. If you want to type it, go ahead. If you are quick, you can catch it. I go onto it. This is live. So you see the time here is exactly the time here, just in UTC. So the load balancer has been configured, ECS has been configured, and a simple PHP app on Apache is served. And the same for Fargate as well. This one here is a different load balancer that was configured, also running as Fargate ECS2. And now, as we are almost out of time, I go back to EC2. I show you two last things here. The first one is the two ECS hosts. So these are part of the ECS cluster for the EC2 launch type. So these two Docker hosts, ECS hosts, they actually run these three replicas that we have launched. And Fargate is not listable. So the other host is just a jump host that has nothing to do with ECS. Fargate is absolutely not listable in this environment. The very last thing I show you is these two load balancers that I have mentioned before. So these two load balancers are configured as well out of ECS. So when we configure an ECS service and define a load balancer, these load balancers here will be configured automatically and will be referenced with the health checks and bound together. Let me see, it's not here. I need to go here. Hopefully it's configured correctly. Yes, you see that here. Here are the three instances that are used. So these are the replicas, and you see here the health checks that are integrated on internal ports on these ECS tasks. Good. That's everything I wanted to show you in this demonstration. And now I need to find my my window again. Which one is it here? Most likely. Oops. That will be fun. I don't need to. I don't need it back. No, it's here. No, here. No. That doesn't matter. Here it is. That's what I wanted to come back to. So we have the demonstration done. I showed you how easy it is to bring up EC2 applications on a predefined ECS cluster. And now I hand over to you for questions. If you have any, please type them into the chat window. Thank you, Mark, for that feedback. I talk now for 45 minutes, that becomes a dry mouth. So good, so with that, we go to the very last slide of this webinar. So thanks everyone for joining, for spending 45 minutes with us. It was great to have you here. Don't forget, on the 14th of December, we have our Kubernetes deep dive and demo with EKS. It will be run in a very similar fashion. Come and join us. Register at copit@clickmeeting.com. Looking forward to see you. Have a great evening. Talk soon. Goodbye.